Hello friends, welcome to another video of SWA Environmental Consultants and Engineers. This is Water and Wastewater Quality Testing Lecture Series Part 1 and this is video number 5. In this video, we are going to learn about the measurement of ammonical nitrogen and organic nitrogen as per method of APHA 23rd edition, method number 4500 which is given for ammonical nitrogen as well as for organic nitrogen. So now let's start the video. So in this video, we will see the introduction of ammonical nitrogen and organic nitrogen. Then we'll understand the principle of measurement for both. Then we will see which equipments will require to perform the procedure. And then we will understand the procedure of analysis in two parts. In first part, we will see the analysis of ammonical nitrogen. And in second part, we will see the analysis of organic nitrogen. Then we will move to the calculation. And lastly, we will discuss about measurement uncertainty. So let's start with brief introduction of ammonical nitrogen and organic nitrogen. So in the nature there are many types of nitrogen available there. Ammonical nitrogen and organic nitrogen are one of them and generally they occurs naturally. Ammonical nitrogen is generally present in ammonia form and organic nitrogen is present in nature various forms like urea, protein, amino acids, amides, amines, etc. Excessive amount of ammonical nitrogen or organic nitrogen in water bodies can cause eutrophication. Okay, so this eutrophication can harm the water quality as well as the biodiversity of the water body. Permissible limit for ammonical nitrogen is 50 milligram per liter and for organic nitrogen it is 50 gram per liter separately. Combinedly, the organic nitrogen and ammonical nitrogen are referred as total Gildan nitrogen because the ammonical nitrogen and the organic nitrogen are measured by the Gildan method. Okay. So this Gildan, due to this Gildan distillation method, they are measured. So it is known as, it is referred as total Gildan nitrogen, and the permissible limit of total Gildan nitrogen is 100 milligram per liter as per CPCB standards. So this was the introduction. Now let's understand the principle of measurement for the process. Now we will understand the principle of measurement of measuring ammonical nitrogen as well as measuring the organic nitrogen by the method of Gildan distillation process. It starts with the ammonical nitrogen. So basically ammonical nitrogen can be determined by the titration against standardized H2SO4. So for titrating this ammonical nitrogen, we have to distillate it first. So we have to make the pH 9.5 with the help of NaOH and fix the pH with the help of buffer solution. So at pH 9.5, ammonia present in the sample will get distillated due to the alkaline medium that we have provided to it. At 9.5 pH, the hydrolysis of organic nitrogen and cyanides will get decreased. Only ammonia will get liberated. So this liberated ammonia will get collected in indicating boric acid at the end of distillation assembly. It will get condensed and after the ammonia is collected, it will get titrated against H2SO4 and we can calculate the amount of ammonia present into the sample. For organic nitrogen, whatever residue is remaining after performing the procedure of ammonical nitrogen will get digested with the help of digestion reagent. The digestion reagent containing H2SO4, CuSO4 and K2SO4. So after the digestion is completed, the organic nitrogen which is present into the residue will get converted into ammonical nitrogen or ammonium. So after the organic nitrogen converts into ammonical nitrogen, the alkaline medium is provided to the sample with the help of sodium hydroxide and sodium thiosulfate reagent. So this sodium hydroxide and sodium thiosulfate reagent provides the high alkaline medium. So due to this high alkaline medium, the ammonia will again get distillate and will absorb into the indicating boric acid. After it is condensed into the indicating boric acid, it again we can titrate it with the help of H2SO4 and we can calculate the amount of organic nitrogen present into the sample. This was brief understanding of the principle for both ammonical and organic nitrogen. In step-by-step procedure, we will understand more about it. So now let's see which type of equipments will be required to perform this procedure. So in reagents, we will require 6 normal NaOH, which will use to adjust the pH of the sample. Then borate buffer solution, which will help us to fix the pH of the solution. Then indicating boric acid, this will work as absorbent. Sulfuric acid 0.02 normal, which will work as titrant in this process. Then the digestion reagent to digest the residue of ammonical nitrogen, and it will eventually convert the organic nitrogen into ammonical form, which we will understand in the procedure again. And lastly, we will require sodium hydroxide and sodium thiosulfate reagent, which will provide highly alkaline medium for distillation process. The procedure of preparing all these reagents are given in annexure. You can refer to the annexure and you can know the exact procedure of preparing all these reagents. So in instruments and glasswares, we will require Geldal assembly, heating mantle, conical flask, measuring cylinder to measure the sample, pipette for adding the sample and reagents, and the burette for titration. So these are basically the instruments and glassware we will require to perform this process. So now let's see the step-by-step procedure for measuring the ammonical nitrogen. As we have discussed in content slide that we will going to see these procedures in 2 parts. In first part, we will understand the procedure of analysis for ammonical nitrogen, and in the second part, we will understand the procedure of analysis of organic nitrogen. So let's start with part 1, measurement of ammonical nitrogen. So now let's start the procedure of measuring ammonical nitrogen. We will measure first the ammonical nitrogen, then after we will measure organic nitrogen into the same sample. So let's start this. So ideal sample taken in this process is 250 ml. So you can see the table on your screen. If you suspect the higher amount of ammonical nitrogen is present into your sample, you can dilute as per your requirement as per given in table. Okay. So here we are taking the sample of STP outlet. So between 5 to 10, the total amount of nitrogen may be present into the sample. So let's measure it first. So we are taking a whole 250 ml of sample into measuring cylinder. So after measuring the sample, add 20 ml of borate buffer solution into this sample. Okay. So add this borate buffer solution into the sample. After that, adjust pH at 9.5 with the help of 6 normal NaOH. So here we are having 6 normal NaOH. So let's add approximate 1 drop of NaOH. So add the 250 ml of sample into this distillation flask. After adding the sample, add few glass bits into it to avoid any excessive boiling while the distillation process. After adding glass bits into the distillation flask, measure 50 ml of boric acid, indicating boric acid into the conical flask. So here we are having indicating boric acid here. Measure 50 ml of it. Add the boric acid into conical flask. Now the reagents are ready to get distillate. So let's set up the distillation assembly. So after we have taken the sample, let's set up the assembly first. So here we are having this boric acid, 50 ml of indicating boric acid. Make sure the tip of condenser is dipped into the boric acid. So basically what happens during distillation is we have made the condition of the solution alkaline. We have settled up the pH at 9.5. So when the solution will get heated by the heating mantle, the nitrogen which is in form of ammoniacal, it will get liberated. It will get condensed into this boric acid. To trap that ammonical nitrogen into the boric acid, this boric acid will work as absorbent. So to trap that ammonical nitrogen into this boric acid, make sure the tip of the condenser is dipped into the boric acid. If the tip is not dipped into the boric acid, the ammonical nitrogen will get escape and you will have error in the results. Now let's set up the assembly. After setting up the assembly, make sure you switch on the continuous water flow, because when the heating mantle will heat the solution will get evaporated and this assembly will get heated. So by this continuous flow of water, the air portion of the sample will get condensed into liquid and we will get the condensate into this boric acid. Okay, so let's switch on the heating mantle, set the temperature at 100 degrees centigrade and let the distillation happens. Collect approximately 150 to 200 ml of condensate. If ammonical nitrogen is present into the sample, this purple color of boric acid will get converted into pale green color. After that, we will measure the ammonical nitrogen by titrating it with H2SO4. So here we have collected the distillate. After the distillation of ammonical nitrogen, you can see we have collected approximately 200 ml of distillate. Now we will titrate it with 0.02 normal standardized H2SO4. The standardization process of H2SO4 is given in annexure. You can refer to that and you can get accurate normality of H2SO4. We have filled the burette with 0.02 normal standardized H2SO4. Now we will titrate and note the reading, and after that we will move to the calculation part. So let's titrate this ammonical nitrogen distillate. So as you can see, the purple color is visible. Endpoint of titration is the purple color. The ammonia which is present into the sample will get neutralized by the H2SO4 and the color of boric acid will appear again. So whenever the boric acid color appears, stop the titration and note the reading. Here we can see the reading is 3.4 ml. Now we will note the reading. Now we will see the measurement of organic nitrogen. So I want to make here a point. If you require the both ammonical nitrogen and organic nitrogen, then you have to perform the measurement of organic nitrogen immediately after distillation of ammonical nitrogen. Okay, but in case you only require the organic nitrogen, so for that you have to perform the distillation process of ammonical nitrogen and remove the ammonia from the sample, but you do not have to collect the condensate. So after the ammonical nitrogen or ammonia is removed from the sample, you can move to the digestion of the organic nitrogen. Now let's see how we can do that. So now let's start the measurement of organic nitrogen present into the sample. This is the remaining residue of ammonical nitrogen distillation process. This residue is containing organic nitrogens into it. Add this digestion reagent. This digestion reagent is made up of potassium sulfate, copper sulfate and sulfuric acid. In presence of all these three, the organic nitrogen which is present into the sample will get converted into ammonium form. So the converted ammonium form will get again measured by the same distillation process that we will see after the digestion process. So first add 50 ml of digestion reagent into it slowly and let the sample get digested till 25 to 50 ml of the solution is remaining into distillation flask. After that we will move further. So now after the digestion is completed, take out the distillation flask. Make sure you wear gloves because the distillation flask is high in temperature, or else let the distillation flask cool down at room temperature. So we are taking this distillation flask. Firstly add 300 ml of distilled water into it. Add the distilled water slowly. So now when distilled water is added, add 50 ml of sodium hydroxide, sodium thiosulfate solution. Tilt the flask. So you can see the color is changing. Shake it slowly and add the whole 50 ml of sodium hydroxide, sodium thiosulfate solution. Now, this residue which is digester, this contains the converted ammonical nitrogen into it. The organic nitrogen is converted into ammonical nitrogen, and again we have made this solution alkaline by adding the sodium hydroxide and sodium thiosulfate solution. So again the solution, the sample is in alkaline condition. So when we will distillate this, the ammonium form of nitrogen will get liberated, and again it will collected in boric acid the same way it was in ammonical nitrogen. So set up the assembly. Again measure the 50 ml of indicating boric acid and set up the assembly same way we have set up it in ammonical nitrogen practical. So again make sure the tip of the condenser is dipped into the boric acid. After setting the assembly, make sure again you switch on the continuous flow of water and switch on the heating mantle at 100 degrees centigrade and collect approximate 150 to 200 ml of distillate, and then we will move further for titration. Here we are having the distillate collected after the distillation of organic nitrogen. Here approximate 200 ml of distillate we have collected. Again this distillate is containing the ammonical nitrogen, and we will titrate it again with 0.02 normal standardized H2SO4. The H2SO4 will neutralize the ammonical nitrogen present into this distillate, and color will again change back to the color of boric acid, which is purple color. So whenever purple color appears, stop the titration and note the reading. So let's titrate this sample. So you can see the purple color is appeared, and this is the end pointer of titration. So the reading is 4.1 ml. Note the reading and let's move to the calculation part. So now let's see the calculation of ammonical nitrogen as well as organic nitrogen. For ammonical nitrogen, the formula of calculation is V into N into 14 into 1000 divided by volume of sample in ml. So here V stands for the burette reading which we got while the titration. N stands for the standardized normality of H2SO4. So the standardized normality of H2SO4 which we have taken is 0.02 normal. 14 is the molecular weight of nitrogen gram per mole, and 1000 is the conversion factor of gram to milligram. So this is the terms. Now if we apply the values to this formula, so the answer comes as 3.4 multiplied by 0.02, which is the normality, into 14 into 1000 divided by 250, which we have taken the sample. So the answer will be 3.8 milligram per liter for ammonical nitrogen. Same formula applies for the organic nitrogen also, but here the burette reading will be different. So for organic nitrogen we got the burette reading 4.1. So the answer will be 4.59 milligram per liter. So this was the calculation of ammonical nitrogen and organic nitrogen. So for total gel nitrogen, as we have discussed in initial slide, that ammonical nitrogen and organic nitrogen combinedly referred as a total gel nitrogen because both are measured by the method of gel distillation. Okay. So if you require total gel nitrogen, then you have to sum the ammonical nitrogen and organic nitrogen. So answer will be 8.39. So 3.8 plus 4.59 will come as 8.39 milligram per liter. So this was about the calculation of both ammonical nitrogen and organic nitrogen. Now let's move to the measurement uncertainty. So now let's see the measurement uncertainty data for ammonical nitrogen first. So the 200 microgram per liter ammonical nitrogen the standard solution, which contains fluoride, nitrate, and other interferences too, was analyzed by 21 participating laboratories, and the standard deviation for that was 69.8. Same goes with the 800 microgram per liter ammonical nitrogen. 20 laboratories was analyzed the sample, and the standard deviation was 28.6%. For 1500 microgram per liter ammonical nitrogen standard, 21 laboratories analyzed the sample, and the standard deviation was 21.6%. For SWA lab, 9.1 milligram per liter of standard solution was analyzed, and the standard deviation derived was 10.54%. So this was about the measurement uncertainty of ammonical nitrogen. So yes, this was it about the ammonical nitrogen and organic nitrogen measurements. So I hope you understand everything. If you have any doubts or any questions, you can comment down. And if you have any suggestions for us to improve our qualities of video, again, the suggestions are welcome. We will soon make another video for another parameter. Till then, take care of yourself. Take care of the environment around you. And yes, please subscribe. Bye-bye.